Now I am going to solve the fourth problem. Fourth problem, LHS is equal to 2 tan inverse 1 by 2 plus tan inverse of 1 by 7. Okay, now here also a formula is there. 2 tan inverse x is nothing but tan inverse of 2x by 1 minus x square. A formula is there. Like this 2 tan inverse. It is tan inverse of 2x. X is 1 by 2 by 1 minus 1 by 2 square. Okay, now it is tan inverse 1 by 7. It is tan inverse, it is 1, 2 cancels and 1 minus 1 by 4. It is tan inverse 1 by 7. Okay, now it is tan inverse of 1 by 4 minus 1, 3 by 4. It is 4 by 3 at last. It is tan inverse 1 by 7. Okay, now? Yeah. And again, the same formula, the third one. It is tan inverse of tan inverse x plus tan inverse y is there. Here you see x is equal to 4 by 3 is greater than 0, positive. Y is 1 by 7 is also positive. Xy 4 by 3 into 1 by 7, 4 by 21 is less than 1. So, we may apply that formula tan inverse of x plus y by 1 minus x y. It is tan inverse of 4 7s 28 plus 3 na LCM by 21 by it is 21 minus 4 by 21. Here also like this. Okay? Simplification. 21 cancels. It is tan inverse 28 plus 3 is 31. 21 minus 4 is 7. That is RHS. Okay, na? Is it clear? Yeah. Okay, na? Like this we have to prove the problems. Yeah, pass. Okay. Now I am going to solve the fifth problem. The set of these 6 problems I have to make it as in the simplest form. Simplification. Okay, now? Right. The first, the fifth one. You see, we are given the fifth problem as tan inverse of root 1 plus x square minus 1 by x is there. Okay, now? Here, we are given some condition also. The conditions are essential to prove the properties only. But it is a problem. We have to simplify it, not to prove it. Here, why we are given x not equal to 0 means in this fraction, x is in denominator. X should not be 0. That is the meaning. Okay, na? So, you simply leave down this one. Now, we will go to this one. Put x is equal to tan theta. Okay, na? Then automatically theta is equal to tan inverse x. Tan goes to the side, tan inverse x is equal to theta. It is useful. Now, this is tan inverse of root 1 plus tan square theta minus 1 by tan theta. Okay, now? It is tan inverse of root of 1 plus tan square theta in the ratios, trigonometric ratios, formula is there. It is secant theta. Root of 1 plus tan square theta. 1 plus tan square theta. Secant square theta. Root of secant square theta is secant theta minus 1 by tan theta. It is nothing but tan inverse of, by changing it, 1 by cos minus 1 by sin by cos. 1 by cos minus 1 by sin theta by cos theta is there. This is 1 minus cos theta by cos theta by sin theta by cos theta. So it cancels, we get 1 minus cos theta by sin theta. 1 minus cos theta by sin theta will be there after simplification. And again it is tan inverse of 1 minus cos theta is 2 sin square theta by 2. The formula is there. Sin theta is 2 sin theta by 2 cos theta by 2. Okay na? Okay na? You see in the multiples and multiples second chapter, you see sin 2a is 2 sin a cos a. Here only. Then sin a. 2a is there in LHS and RHS it is a1. 2a, half of 2a is a. Then sin a is there, it is 2 sin a by 2 cos a by 2. Okay, na? Half angle. Like this, suppose it is theta, then it is theta. Like this. And it is also one formula. 1 minus cos 2 theta is 2 sin square theta. Formula is there. Cos 2 theta is 1 minus 2 sin square theta. And 1 minus cos theta. For 2 theta LHS, in RHS it is half angle theta 1. 2a is a1. 2 alpha is alpha. Like this 2 theta is it is theta, then it is reduced to theta means it is theta by 2, half angle. Okay, then try to understand. So 2 cancel, sin 1 square is cancelled, then it is tan inverse of 1 sin is there, square, 1 sin is there, sin theta by 2 by cos theta by 2 is tan theta by 2. Okay, now tan inverse of tan cancels, it is theta by 2. That means 1 by 2 into theta. It is 1 by 2. What is theta? Theta is tan inverse x. So that is it's the simplest form. Okay, now you try to follow it 1 or 2 times, 3 times. You repeat the video and slowly you observe it. It is your duty now. Because if it is class is in live, then I will call you and or at least I will come to you and I can clearly tell in the on paper. But here not like that. But it is also on positiveness is there. It is also because in the live, if I teach the class and I will go on, yes, it is over. Again I have to come and take the class. But it is not there like this. It is repeat. You can how many times you want, you can repeat the same steps. Okay, na? Try to understand. Slowly you learn it. Okay, na? Next, I'll go to the 6th one. I'm writing here the 6th one. It is tan inverse of 1 by root of x square minus 1. Here also a condition is there. When the condition is in problems, needed to solve it. Even though I want to tell you why it is given, but it is not necessary to write in the proof of this problem in exams. You see, what is mod x greater than 0? Why? Because this is root, okay na, x square minus 1, root is there. Anything in the root is must be greater than 0. It must be positive. Okay na? root, a positive number can be defined. Root of 0 also can be defined. But it is in denominator. So don't put a equal. It must be positive. So it is x plus 1 of x minus 1 greater than 0 na? Okay na? So anything is like this, x minus alpha of x plus beta is greater than 0. It is in lower classes properties there. X either it is less than minus 1 or it is greater than 1. That is nothing but mod x like this is given. Okay na? But it is need not to learn it. You simply leave it out. No bother. Now only this one. I am going to here. I am erasing this fifth problem. Observing. You see, put x is equal to secant square, secant theta. Just you assume secant theta. Then secant inverse x is equal to theta na. Okay na? Okay na? Then x is secant theta. Now it is tan inverse, I am taking that one, tan inverse 1 by root of secant square theta minus 1. Will you agree? Yeah. This is tan inverse 1 by, this is secant square theta minus 1. 1 plus tan square theta is equal to secant square theta. In the previous problem also we solved it. Okay now? Then what about the tan square theta? It is secant square theta minus 1. Okay now? So here we can write it as root of tan square theta. This is tan inverse of 1 by tan theta. Okay now? It cancels. Okay now? Right. It is tan inverse of cot theta. 1 by tan theta means cot theta. Okay, up to that step we can solve, and here is some problem. A twist is there. Tan inverse of cot, tan inverse cot will not cancel. So we have to write it as tan of pi by 2 minus theta. You agree? Why? Because tan inverse tan cancels. So tan of 90 minus theta is cot theta. Okay. Now we get pi by 2 minus theta. It is pi by 2 minus theta, where theta is secant inverse x. Okay na? So this is its simplest form. Okay? Yeah. Plus. Okay. Now the seventh problem. Seventh problem is, it is tan inverse of root of 1 minus cos x by 1 plus cos x. Here also you leave that conditions not needed, simply leave them. But here this type of formulas are very important. Wherever the mathematics, any branch of mathematics, this type of formulas are very important. You see, once again I want to tell, cos 2x is 2 cos square x minus 1. Then cos x is equal to 2 cos square x by 2 minus 1. Already I solved in the sixth problem. 2x is x. 2x is in the LHS, in RHS x, half angle. Then x is there, x by 2 half angle. You send the minus to this side. 1 plus cos x is equal to 2 cos square x by 2. This is one thing. Similarly, same cos 2x having like this formula also. 1 minus 2 sin square x. Then what is cos x? 2x is x. X is 1 minus 2 sine square x by 2. 2x is x. Then x is x by 2. Half angle. You send to that side, this side. It is 2 sine square x by 2 is 1 minus cos x. Okay, na? If 1 minus cos x is as 2 sine square x by 2. 1 minus cos theta is as 2 sine square x theta by 2. Like that. 1 plus cos theta means it is 2 cos square theta. Line is it is tan inverse root of this is 2 sine square x by 2 cos square x by 2 is there. Okay, na? This tan inverse 2 cancels, squares root cancels, we get tan of sine by cos is tan x by 2. Okay, na? Yeah. Okay? Yeah. Right, this tan inverse of tan cancels, it is x by 2. That is 1 by 2 into x. Okay, na? Like this. Only I think only it is there. It's the simplest form is x by 2 is enough. Okay. Right. Next we'll go to 8th one. It is tan inverse. It is cos x minus sin x by cos x plus sin x. Tan inverse of, take cos as common. Cos of 1 minus sin x by cos x by, again in the denominator cos x is taken as common, it is 1 plus sin x by cos. Cos x cancels, it is tan inverse of 1 minus sin by cos is tan by 1 plus tan x. 1 minus tan x by 1 plus tan x. A formula is that, you see, I am solving this formula, you see, 1 minus tan x by 1 plus tan x means 1 is tan pi by 4, tan 45. It is tan x by 1 as it is 1. 1 tan x is there, 1 tan x is there. That 1 is again tan pi by 4 tan x. You say this is tan of pi by 4 minus x. Tan a minus tan b by 1 plus tan x. So it is tan inverse of tan of pi by 4 minus x. Okay, na? Tan inverse cancels. We get only pi by 4 minus x. Okay, na? So that is the simplest form of this 8th one. Now, okay, is it clear? Now, 9th one. It is tan inverse x by root of a square minus x square. It is also the condition. There also, you see, under the root must be greater than 0, must be positive. May be equal to 0, but it is in denominator, so it will not equal to 0 here. So it is x square minus a square means it is less than 0. I am just interchanging it. We are getting some minus. So this inequation will be changed. Greater than will become as less than. It is x plus a of x minus a less than 0. Okay, now. So x belongs to minus a comma a. This is a formula. It is in the lower class of studies. That means x is in between minus a and a. Or otherwise, we may write it as mod x less than a also. So this much of concept is there. But it's not needed. You simply by heart that one. We'll try to learn this one. Now, put x is equal to a sin theta. I am taking a sin theta. Then x by a is equal to sin theta. No? Then theta is sin inverse x by a. No? Okay, na? In our assumption only x by a sin theta. Theta is sin inverse x by a. Okay. Right. Now, it is the tan inverse of a sin theta by root of a square minus a square sin square. This is the tan inverse of a sin theta by root of a square of 1 minus sin square theta. Okay, na? Okay, na? I am taking a square as common, 1 minus sin square theta is there. It is tan inverse of a sin theta by root a square is a root of 1 minus sin square theta is simply cos theta. A cancels, you get tan inverse of tan theta. Okay, na? So cancels, you get theta. What is theta? It is a sin inverse x by a. Okay, na? So this is the simplest form. Right. Is it working now? Yeah. Now, I'm going to solve the 10th one, the last one. Tenth problem. Tan inverse 3a square x minus x cube by a cube minus 3a x square. It is somewhat a clumsy problem. It is also asked in the theory exams. Observe. You know this condition. Simply leave it out. You say it is tan inverse of. I want to take a cube as common. Then it is 3a square x by a cube minus x cube by a cube by. Here also a cube as common. It is a cube by a cube minus 3a x square by a cube. Don't confuse. What is the necessary to take the a cube as common is a doubt for you. After solving this totally the problem, you can understand. If a cube is taken as common means here in the two terms no a cube. Even though I am multiplying a cube and dividing a cube. Like that also you can assume. Here also multiplying with a cube and dividing with the a cube. That is the meaning. Now a square, this cube cancels, so a is there. Here x by a whole cube is there. It totally cancels, 1 is there. Here also a square cancels, a cube cancels, 1 by a square, x by a square. So at last it is tan inverse of, it is 3x by a minus x by a whole cube by 1 minus 3x by a whole square is there. It is just like, say, I will write it as 3 alpha minus alpha cube by 1 minus 3 alpha square is tan inverse of 3 alpha minus alpha cube by 1 minus 3 alpha means it is 3 tan inverse alpha. A formula is there. In properties we solved it. Okay, na? Alpha means here alpha. Alpha is simply x by a. I am taking like this. Okay, na? It is a 3 tan inverse. What is alpha? Is a x by a. Okay, na? Okay, na? Like that we have to solve it. So it is an important problem. So I will write here, these are the important problems. Okay, na? All these are asked in the previous exams. Okay? Right. Stop.